Hello, in this video, I would like to share with you methods of calculating probability of both independent and dependent events. To find the probability of two events occurring together, you have to decide whether one event occurring affects the likelihood of the other event occurring. When one event affects how a second can occur, the events are known as dependent events. Otherwise, they are known as independent events. Consider the following pairs of events. Can you tell which of these are dependent and which of these are independent events? In the first case, picking a card from a deck of cards and rolling a single die do not affect one another. The result from picking the card will not influence how the die will be rolled, so we will call these independent events. What if you pick a card at random from a deck, replace it, then pick another? Since the first card was placed back into the deck before the second was chosen, it did not influence the second pick. The exact same set of cards were available for the second choice. Therefore, this is a pair of independent events. Had the first card not been replaced, then the pair would be considered dependent, since the makeup of the deck for the second choice was different than the first. Not replacing the card would be the same as choosing two cards from the deck. Finally, what if you roll two separate dice? These are independent since the outcome of the first die does not affect the second. Let us now look at the method for computing the probabilities of independent events. In order to calculate the probability that both independent events A and B occur, we simply multiply the probability of event A occurring times the probability of event B occurring. For example, we said that picking a card, then rolling a single die are independent events, so the probability of picking a king from a deck of cards and rolling a 5 on a die would be 4 out of 52 times 1 out of 6. Since there are 4 kings in a deck of 52 cards and only one 5 on a 6-sided die. It is common to reduce the resulting fraction into a decimal by dividing the numerator by the denominator. In the second example of independent events, what's the probability of picking a king, replacing the card, then picking a red card? In this case, the probability would be 4 out of 52 times 26 out of 52. Please try the last example on your own. Pause the video now and resume playback in a moment to check your work. Since these events are independent of each other, and there is a 3 out of 6 chance of rolling an even number, then 3 out of 6 chance of rolling an odd number, the product of these two probabilities is 9 out of 36, or 0.25. The method for computing whether either of two independent events occur rather than both is slightly more involved. We first sum the probabilities of A and B, then subtract the probability of A and B. It is more likely that one event or the other will occur rather than both. For example, there is a better chance that you pick a king from your deck of cards or a 5 rather than a king and a 5. You might find it easier to convert each probability to a decimal first. This eliminates the need for adding and subtracting fractions. Please try the last two on your own. You'll notice that they also use the same premises from before. Pause the video now and resume playback in a moment to check your work. With regards to dependent events, the method becomes more complicated still, since one event's outcome affects the probability of the other event occurring. The probability that event B will occur given that another event A has already occurred is called conditional probability. Conditional probability exists when two events are dependent. A two-way frequency table, or contingency table, is a table that contains data from two different categories. It can be used to simplify the process for calculating the probability of conditional or dependent events. For example, this table shows two categories: the location and educational level of its employees in a company. What is the probability that a randomly selected person works in Ohio, given that they have earned a high school diploma? When we say the phrase "given that," we are implying that we're only interested in those that earned a high school diploma and not any other educational level. So for this example, we see that there were 1,156 employees in Ohio with a high school diploma. And a sum total of 5,661 employees with a high school diploma. Therefore, the probability is 1,156 out of 5,661. If we reverse the phrasing, we see a different answer. Another way to think of this is by asking yourself, of those from the state of Ohio, how many have earned a high school diploma? The previous example might be reworded as, of those that earned a high school diploma, how many are from Ohio? This should help you see why the probabilities are different. Please try the last example on your own. Pause the video now and resume playback in a moment to check your work. To finish this video, I'd like to share with you the formula needed to compute conditional probability. As long as the probability of the first event occurring is not zero, Then the probability the second event occurs, given that the first event occurs, is the probability of both events occurring divided by the probability of the first event. I encourage you to try using this formula to check our work for the last 3 examples. Good luck.